All right, let's dive right in. We're going to talk about one of the most powerful and, let's be real, one of the most misunderstood technologies out there today, deep learning. You've heard the term, for sure. It's the engine behind so much of the AI we see everywhere. So, in this explainer, we're going to pull back the curtain and really get a feel for how this stuff actually works.
All right, so to really get our heads around deep learning, we've got to start with a core mystery. Seriously, it's the simple but really profound paradox that had AI researchers scratching their heads for decades. And, it's this very paradox that ended up paving the way for the whole deep learning revolution.
Okay, so check this out. How is it that a computer can absolutely master chess? I mean, a game that's a huge deal for us humans to get good at, but then it completely struggles with something a toddler can do without even thinking, like just recognizing a cat in a picture? The whole answer, it turns out, is about rules. Think about it. Chess has a very small, very clear set of formal rules. But recognizing a cat, good luck writing the rules for that. You'd be like, okay, it's got pointy ears, well, unless they're folded over, and it's furry, except, for the hairless ones. You see how impossible that gets? That problem, right there, is why we needed a totally new way of thinking.
So, how did we get past this roadblock? Well, it took a massive shift in how we even thought about the problem. The big idea was this. What if, instead of having human programmers try to write an infinite list of rules, we could build a system that learns the rules on its own, just by looking at data? You can really see the two approaches here. On one side, you've got the old-school rule-based AI. This is where programmers would sit down and painstakingly code every single rule for a closed system, like a game of chess. It worked, sure, but it was super brittle. Break one rule and the whole thing falls apart. But on the other side, that's machine learning. Here, the whole game changes. Instead of being fed rules, the system learns them itself, just by churning through mountains of data. And it turned out, this was pretty much the only way to build AI that could actually function in the complex, messy world we live in.
Okay, so where does deep learning come into the picture? Well, it's a specific kind of machine learning, and it is incredibly powerful. The real secret sauce, the thing that makes it so special, is right there in the definition. It learns to represent the world as a nested hierarchy of concepts. So it's not just learning one giant, complicated rule. It's building up its understanding piece by piece, layer by layer.
Okay, let's really dig into that idea. Because this whole concept of a hierarchy is the absolute beating heart of deep learning. It's the magic trick that lets a machine go from staring at a bunch of meaningless pixels to actually understanding an abstract concept, like, oh, that's a cat.
So let's go back to that cat photo. At the very first layer, the model doesn't see a cat at all. It doesn't even see fur or whiskers. It just sees pixels. And from that raw mess of pixels, it learns to spot the most basic building blocks imaginable. We're talking simple stuff like horizontal lines, vertical lines, maybe some corners. This is like the absolute ground floor of seeing anything.
Now the next layer up, layer 2, takes all those simple lines and corners from the first layer and starts putting them together. So maybe it learns that a certain combination of curved edges and a dark spot usually means eye, or that these two diagonal lines coming together look a lot like an ear. It's literally assembling the puzzle pieces.
And then, finally, a higher layer takes those parts, the eyes, the nose, the ears, and learns to put them together into something way more abstract, a cat's face. And here's the really wild part. The model figured all of this out on its own, building from simple to complex, just by looking at a ton of data. That is the power of this whole hierarchical thing in a nutshell.
Okay, at this point, you're probably wondering, what's actually doing all this learning? Well, under the hood, it's all math. But hey, don't worry, we're not about to break out the calculators or solve any equations. We just need to get a feel for what each piece of the puzzle does. So just think of it like a toolkit with 3 main tools. First, you've got linear algebra. That's basically the language and the plumbing for the whole network. It's what lets the data flow through all those layers we talked about. Next up is probability theory. This is super important because the real world is messy and uncertain, right? Probability lets the model make its best educated guess. And finally, you have optimization. This is the engine. It's the process that's always tweaking and adjusting the network, trying to make its errors smaller and smaller. It's what makes the model get a tiny bit smarter with every single example it sees.
So this basic idea of learning in layers, this hierarchy, it's so powerful that people have created specialized versions of it for different kinds of jobs. Let's take a quick look at a couple of the heavy hitters in the modern AI toolkit.
First up, we have convolutional neural networks, or CNNs for short. You can think of these as the vision specialists.
Their whole structure is built from the ground up to deal with grid-like data, which is exactly what an image is, right? A grid of pixels. In fact, that whole process we just described, learning edges, then parts like eyes, then a whole face, that is exactly what CNNs are designed to do. When it comes to computer vision, these things are the undisputed champs.
But okay, what about data that isn't a neat grid? What about something that unfolds over time, like a sentence you're reading or a piece of music? For that, we have another tool, recurrent neural networks, or RNNs. These are the sequence masters, and their big trick is that they have a kind of memory. It allows them to remember what came before, which is absolutely crucial for understanding the context and language or any other kind of sequential data. Okay, so we've seen that these models are amazing at recognizing and understanding stuff in the world. But now, here's where things get really, really interesting. The new frontier is all about what happens when you flip that whole process around. This brings us to the wild world of deep generative models. Just think about this for a second. After a model has learned the patterns of what a cat looks like from seeing thousands and thousands of photos, it can then be used to generate a totally new, completely realistic picture of a cat that has never, ever existed. The same goes for language. After learning the patterns of text, it can write brand new sentences, even whole articles. We've moved beyond just recognizing the world to actually creating new things in it. And that really brings us to the final big idea here. At its heart, deep learning is all about building these deep, layered representations of our world. So as these models get more and more powerful and their understanding gets more and more nuanced, it leaves us with a really fascinating question to chew on. What will they help us understand next? Not just about the world around us, but maybe even about ourselves. Something to think about. Thanks so much for joining me on this one.